Hello guys, and welcome back to another part in my DIY analog synthesizer tutorial videos. Now in this particular video, it's not going to be so much focusing on how to build the circuit, which I've kind of covered in a few of the other videos. It's going to kind of be more my kind of my sort of breadboarding techniques and tips, which you guys may find useful. Right, so basically what I'm going to build here is the sawtooth, or should I say the saw core oscillator. Let's try and get that into the camera properly. As we can see around this part here, if we look at here, we have the V2 op amps and our setup, as we can see. So we're going to ignore anything else here, which is basically wave shaping. As you can see here, we've got 4 op amps, and these 4 op amps are all contained within this quad operational amplifier, which we could use a TL074. If we're going to make an LFO, we could use something like a LM348, or I think it's the 324, not 100%. Now, first thing what we need to do is find out where our pin 1 is. We'll normally have a little notch at the top, or we'll have a small dot. Now, what I have here is the AD01 breadboard, which you can get from Maplins, which basically is what I've used in my project. I've used quite a number of these, and we have sets of power rails. When I first started building my project, what I did was use this row here as the positive or plus voltage, and the top line as a negative voltage. However, what I found about what was happening over time, I was getting shorts and nothing was working, and batteries were frying, and then I suddenly did a continuity test and pinned it down to be there's some kind of crossover. So to keep things nice and separated as possible, what I do is I'll put this side will be my minus voltage, and this will be my plus voltage. Now, if we're going to populate this breadboard and use quite a few bits, if we look here on the positive rails, we're going to use the top one as the positive rail. What we need to do first is, if we look at these red lines, this is where the links are. So all this row is linked positive and here. So what I normally do is, so I can have one incoming positive, is place that there. So now we have a continuous positive voltage path throughout this whole thing, and we have a continued negative voltage here. Right, so first things first, we're going to take our quad op amp, get it the right way round, and it should be a 14-pin dual inline chip. Place it on the breadboard. Now, in case you're not too familiar with these ICs, I really strongly suggest you go and look up the data sheet. They're pretty much the same setups for all quad op amps as far as the power rails are concerned. We normally take pin 4 to plus voltage, and pin 11 to negative voltage. Now, what I use for my connections is not the kind of prefabricated jumper wire which you can buy. What I use is cut Cat5 cable. So you could buy a big reel of Cat5 cable, a couple of meters, and you would get, say for instance, you'll get an orange, a green, a brown, and a blue, all in one meter, plus you'll get 4, so you've literally got 4 pairs. So that's quite a lot of meterage for the money, to be honest with you. And it means you can kind of cut your cables to length and keep sort of any sort of what's the word, things like inductance and stuff that you'll sort of bring into your circuits, rather than using a big looped wire. You keep your runs to a very minimum, cut them to whatever size you want. Now, the cable tools that I use is basically this, for where I can't get my fingers in, pinching out components, a pair of side cutters to cut down the cable to length, and a pair of these. Now, if you can see these have a small notches, a couple of cutting notches here. So what we'll do is we could use a cable. We could do something like this. If you want to say, for instance, we wanted to strip this part, this particular bit of cable. So I'm just going to pre-cut this so there's no stripping on it. So what I do is I take the cable here, and then I'll grab, not pinch it too hard, just enough to bite into the actual insulation, and then strip, and then we see there we have our copper exposed. Right, so what I'm going to do now is take pin 4 of the op amp and put that into the positive rail like so, and then I'm going to take pin 11 to the negative rail. Stage 1, again follow our schematic. Now what I'm going to have to do is we're going to link pin 5 to pin 2. So here again I have another pre-cut piece of wire, and I'm going to place pin 2 into pin 5, and it's very important you try and have a count of the pin as you go along. Make sure you're not hitting the wrong place, because you can end up frying your op amp when you turn it on, when you power this bad boy on. And secondly, what I'm going to do now is make a voltage divider, which is going to go from pin 2 again, so from pin 2 to pin, so pin 2 and pin 2, I'm going to use 200k resistors. One is going to go to the positive voltage and one is going to go to the negative. So again, just pop that in nicely, make sure that's nice and snug sat in there. Let's see if I can find one. Here's one I made earlier, and pop that in. Some of you guys probably have other techniques that you use, but yeah, it would be nice if you guys could share that with us as a community. I'm not saying my way is the only way you can do it. There's many ways you can do things like this. And another important tip I would say is, if say for instance you've got a heavily populated area with these wires exposed, especially to the power rails, what I would suggest you do is take, say for instance, a white cable, strip a little bit of insulation down and insulate those exposed, so we know we're not going to be touching anything or shorting anything out. I've had that a few times where I thought, why is my circuit not working? That's wired up to a T, nothing's happening, and I found that to be my reason. So that's just out of my practice now. That's what I do. So we can see we've got the 100k voltage divider, positive and negative going into pin 2, which is linked to pin 5. We're pretty much nearly there, to be honest with you. So now what I'm going to do is take my 47k, and we're going to be using the positive. In a lot of oscillators we use negative feedback. In this one we go from the output to positive. I think it's something to do with something we call it hysteresis. Don't quote me on that. Not the most technically savvy person. Still a learner like you, some of you guys. Anyway, so what I'm going to do now is take a 22k resistor, and we're going to pop that in from pin 3 to pin 7, and there we go. We can see we have a 47k in a positive loop, 22k from pin 3 to pin 7, and we're pretty much nearly there. We have two components left, and one is our diode, which we definitely need. If we don't have our diode in there, we won't be able to have any voltage control, because at the moment what we will have, if we plot this capacitor in, which will go between pin 6 and pin 7, which will be our timing capacitor. As you can see there, I've used a polystyrene cap if it's an oscillator. If it's an LFO, if it's not a voltage controlled LFO, we don't need to worry about any kind of pitch tracking, etc. Quite a crude method technique. And there we go. So we put that in there, and then we need to take our diode from pin 1 to pin 6. Which I will do, as we can see, that's coming quite heavily populated already. So I'll go from pin 1 all the way into pin 6, and that'll give us our basic saw core. We can test that saw core by taking a cable into any old pin here. I'll put it into pin 1, and then we'll take another cable across and then put that into pin 6. So basically the same pins where the actual diode goes in, and depending on which way our diode is will determine which way we'll either have a saw or a ramp. and then we've taken a potentiometer. If we're doing tuning, I normally go for B type. This is A type because this is what I kind of have left. So we go for a B type, which is a linear as opposed to a logarithmic one. Place it in there, and as you can see, I want to use either pins 1 or pins 1 or pins 2 or pin 2 and 3. So any side will do, depending on which way you want to have your maximum and minimum direction. And just out of practice, what you may also want to do is actually have a stop point. So on either extreme side, what I would do is run a cable to 0 volts, drop that one, 0 volts ground. So once we turn all the way to the 0 volts ground direction, our LFO should stop, and there we have it. So what we need to do after that, I know my wires are a little bit everywhere, but I'm not going to be able to have the time to cut things to precise length here. Just trying to show you as quickly as I can. And there we have our saw core, pretty basic, pretty simple. So we need to power this up. We will take a audio probe and place that into pin 7, which will give us a sawtooth output. And don't forget, if we remove the the diode, we will have a triangle on pin 7, and we will have a square wave on pin 1. And that square wave, you need to be very careful and have a very high output. So what I normally will do is place a resistor between the output and try and keep them level. Say for instance, I'm building this just as an LFO to control, like say for instance my vibrato, and then we can have a switch in between the two. So there we have it. Not a lot more to say about this. Again, if you can see, I've put our ground over here. Some circuits you may find will have lots and lots of ground connections, and way we're governed is by these lines here. As we can see, all these here in this row are connected, and all these other rows going across this way are isolated. So we only have 1, 2, 3, 4, 5, 6 spots to place our ground in at the moment. However, this is a technique what I use a small looping cable. So now we have double that. If we want more, all we need to basically do is loop over again. And again, as you can see, I'm trying to keep all the power connections, as far as the main incoming power connections, as separate as possible. So I use the corners as the ground, 0 volts. And it's very important that we use our multimeter and test for continuity and try and make sure we've got 0 continuity between our incoming power ground, 0 volts, and whether that's batteries or a bipolar power supply. So we've literally got no resistance, because that could cause some problems in some circuit where we actually need that 0 volts to keep our performance integrity. You could run into problems and think, oh, scratch your head, why the hell is this not working? Why are we not completely getting to a certain point? Or yeah, my filter doesn't work properly, etc. I had that problem before, so I just tested and troubleshooted and made sure I had a bit of a dodgy ground. So we make sure we test to make sure we've got 100% good solid continuity, and also along the power rails, just to make sure what we know should be coming in is exactly what's coming in. Batteries, we're going to get a variation. We may not get exactly 9 volts because we could start to drain the battery, but if, say for instance, we measured our power supply and we've got, I don't know, we've got plus 15 in, we may get a small drop if we've got multiple circuits going on, but we should be around that sort of. We just test across, we make sure we've got our plus 15 or our minus 15, and again make sure we've definitely got our continuity for our 0 volts. Right, that's all there is to discuss in this tutorial. Again, like I said, please leave comments, any questions you have, and also if you've got your own techniques which you want to share, leave them in the comments section. And guys, I will catch you very soon with some other sort of small breadboarding tips and techniques that I personally use. Make it your own, people, and enjoy. Alright, catch you soon.